Hello, eligible students. Today we are going to be looking at the third and final day of 11.4. As we've seen so far in this section, we've kind of been just hammering the situations where we're factoring and we're solving by factoring. And today I just want to touch on some of the other situations where we might have quadratic situations where you have an x squared or a variable squared situation where we don't have to factor. There's not always going to be a trinomial where we have that x squared plus that x value plus that constant. That's not always the case. And actually, the cases like this one we're going to start with, where that's happening, or where the factoring is not happening, I should say, they're actually really simple. So I do want to touch on them, though, because we get kind of deer in headlights when we see these after we've been doing all this factoring, and then we see a w squared, and we want to get everything on one side like we did yesterday and try to factor when really we don't have to be doing that. So in this situation, you are looking at just w squared equals 9. Okay? So this is an inverse operation, right? When we have equations that we were trying to solve, when you had equations like w plus 5 equals 12, how did we get the w alone? We did the inverse of adding 5 and we subtracted 5. And that's all that we're going to be doing here is the inverse of w squared in order to get w alone is taking the square root. So we're going to take the square root of w squared. That's going to cancel out. Those are opposites of each other. They negate each other. So we have w by itself now. And what we need to be careful is we've got to make sure we're including both 3 and negative 3 as the possible roots of that for today. Because remember, when you have a w squared, that exponent of 2 tells you that there's 2 solutions. So we've focused a lot at times in the past, especially with certain situations like solving for a distance or a length. That's always going to be positive, right? But when we have the square root of a number, of a positive whole number, you have a positive and a negative root, because all a square root is something that is multiplied by itself to equal that value. And that happens with both positive 3 times positive 3 and negative 3 times negative 3. Those both end up equaling positive 9. Okay? So what I want to kind of touch on here before we move to the other slide, another thing I want to call attention to is this situation. Saying w is a real number, and if there is no solution, click on no solution. So what that's referencing is there is no way with real numbers for something like this to happen. There's no way that you can square a number and end up with a negative answer, right? Because the square root of positive 16, right? The square root of positive 16 we know to be 4. Well, it's also negative 4, right? Positive and negative 4 are going to give you 16. So if we have 4 times 4 equals 16, we know that 4 is that root of 16. And again, a negative 4 times a negative 4 also equals positive 16. There is no way for you to multiply a number by itself and end up with a negative answer, because a negative times a negative gives you a positive. Now, little flash forward to algebra 2, you will be able to take that square root with something called imaginary numbers. I'm not going to go down that road, even though I love talking about it, but that is something that will come in the future. But that is why this word real is here, because the real numbers, the numbers that you all are used to working with forever and ever, the only numbers that exist in your understanding right now, we can't do that. You cannot take the square root of a negative number. So that is where you would just say no solutions on your assignment. Okay. Now, we might kind of be wondering, okay, well, how do I know to just take the square root instead of factoring? Well, excuse me, the only time that you need to factor, let me move this down a little bit, the only time that you need to factor is when we cannot solve by getting a variable alone, right? If you have x squared plus 7x minus 12 equals 0, okay? if you're sitting in this situation, we have two different forms of x that cannot combine into one term. We have an x squared and we have a single x. Those cannot combine into a single term. So we have no way of getting x alone just through our solution steps. You can't solve. Remember when we talked about months of our solution process when we're solving equations, and you've been doing it for years, we always want to get the variable alone. Well, the reason we have to factor in this purple situation up top is because we can't get x alone. The only way to get x alone is to split them apart by factoring, right? That's what we've been talking about for the last couple chapters. So it's very understandable that when we see these problems now where factoring isn't necessary, we don't really know what to do. We've been hammering away at that factoring concept, right? So when you're looking at 90 equals 3u squared plus 6, you've done things like this before. You might not remember it because right now you're in the mode of seeing a variable squared and thinking that we have to factor, but you have done this. This was just another piece tacked on to all that solving that we did with the chapters of solving equations. So all that this has happening is an extra little step at the end. So actually the way I want to look at this is what would you do to solve this if that was just 3u? Your first step would be to subtract 6 from both sides. Very good. You've got 84 is equal to just a 3u. And then we would finish that by doing the inverse of 3 times u. And we're going to divide by 3 so that cancels with the inverse operation. Right? So then what you end up with, 84 divided by 3 is 28. And then you have your u alone. The only thing that's in the way of that right now is this is actually a u squared. That doesn't change anything. All it does is tack on one extra step at the end. Okay? So we have u squared right now. In order to get u alone, since it's just one form of our variable right now, I can go ahead and do that. I can take the square root. So I'm going to take the square root of both sides because it cancels out the fact that I'm squaring, right? So now my u is alone. And then you take the square root of 28 on a calculator because that is not a perfect square. And you're getting a big, long, ugly decimal. They want you to round it to the nearest tenth. And that's going to come out to be 5.3 and negative 5.3. So those would be your two different solutions. Now you're going to also see one way of writing this with this plus minus symbol. That just wraps both of those expressions, or both of those values of positive and negative 5.3 into one expression. So I guess I'm not 100% sure on Alex if they have that plus minus symbol for an option, but that is just a way to shorthandedly express that you have a positive and negative of the same value, okay? Or you could obviously list them at any point like we did in the first box, okay? So that's all that's happening in those problems. If you just have one form of u, you have one form of your variable, you can solve it the same way we've solved equations for a long time, okay? Now we get to the word problem. There is one of these on your homework. This is supposed to be challenging. It should be a little difficult, okay? But we're going to look at how we want to break this down. I think you should all be drawing yourselves a rectangle. Give yourselves an image, something physical to look at. Okay, we know that the area of this is 52 because they tell us that. So in order to find the area of this rectangle, as of right now, we're just cutting off our information right there. I'm not going to read the rest of this yet. As of right now, we know that this rectangle has two things being multiplied together to equal 52. Well, those two things, the formula for finding the area of a rectangle is your length times your width. I think we all know that. Okay? So as of right now, your equation is length times width equals 52. Well, you are not going to be solving, you are not going to be able to solve for your L or your W right now because there's two different variables in the same equation. We can't solve for that. You could solve for it in terms of the other variable. They don't want that. They give us some more information. Now, here's the part That throws a lot of us off. We did this a while ago when you had turning verbal phrases into mathematical expressions. Verbal expressions into mathematical expressions. We did it a little while ago, but just go a piece at a time. Let's break this down, okay? So the length of the rectangle is, basically what that chunk is telling you. Length is represented by L. That word is that equals. So right now we know L is equal to something. So what they're going to do here is they're going to take, since we have two different variables, they're going to use this sentence to let us represent one of our variables, in this case L. They're going to let us rewrite it to represent it in the term of a W expression. So then all we have is W's in our equation, and we're able to go ahead and solve. Okay? So L is equal to something. So now we're looking at this 5 yards less than expression. 5 yards less than. Well, you think about if my brother is 5 years younger than me, his age is 5 years less than mine, you would take my age and just do what? Subtract 5. So 5 less than something is just minus 5. Now 5 yards less than what? Twice the width. You know, the word twice means 2 times something, and the width is represented as that W variable. So you have 2W. So you know right now that your length is equal to 2W minus 5. And in your equation, you are going to replace 2W minus 5 for that L. Okay? That's a substitution step. We've done some chapters on substitution and things like that with systems of equations, right? So what we're looking at right now is a situation where, similar to yesterday, where we need to get this expression into a standard form, or at least expand it a little bit, multiply this W, distribute this W into that grouping, so that we can then break this all apart and get to the place where we can either solve or need to factor. So W times 2W for that first one, that'll be 2W squared. W times negative 5 will be negative 5W, and then we're equal to 52. Now you're looking at exactly the same situation you had a handful of times yesterday. Excuse me. Where we need to get to standard form. We have two different forms of our variables, so we know we're going to have to factor. Get to standard form. So we want to subtract 52 from both sides so that we have everything on one side in standard form. So biggest variable first, 2W squared minus 5W minus 52. We're in the AX squared plus BX plus C form now, and we are equal to 0. Now we know that we're going to be factoring. Your A is not equal to 1, so you're going to have to use the AC method. And then you are going to be able to solve for your length and your width. Now, I am almost out of time here for this video, so I am not going to completely finish this example on the video, but I will finish it on the notes, and then you can look onto the notes to see this example fully finished. Because we're going to need to factor to find our W, okay? Once you find the W, that W represents your width, and then I use that W that I found and plug it in for the W in the expression for L to find my length. This is a long problem. It's a challenging problem. That's okay. You guys can do it. All right? So that is it for the video. I'm going to wrap the video up and check out the notes to see the rest of this problem. And good luck today.